Hi, it's Mrs. Nandor, and in this video we're going to talk about how we draw particle diagrams and how we analyze particle diagrams for density. So let's start with our first example. So we have box A and we have box B, and the particles in A and B look to be the same size. So the individual particles have the same mass. So let's compare the mass. So the mass we defined as the amount of stuff. Well, the particles are the same size, so the particles themselves have the same mass. So we determine which one has a greater mass by counting the number of particles. So A has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 particles, while B only has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 particles. So if the particles are the same size, which one has the greater mass? Well, A has the greater mass because it has more particles. So let's compare the volume of these two. So volume is the amount of space it occupies, so we're looking at the size of the boxes. What do we know about the size of boxes? Well, without getting a ruler out to actually measure the dimensions, those boxes look to be about the same size. So we're going to say they have equal volume. So now we're going to look at how we can compare the densities for these two objects. So they have the same volume, but A has a greater mass in that volume. Since A has a greater mass in the same amount of volume as B, that means A has the greater density. We can also look at this visually with a particle diagram as representing the compactness of the object. So the particles in A are much more compacted than the particles in object B, so object A is much more dense. So the more compact the particles are, the denser the object is. Let's look at another example. So we have object C and object D. Both have 4 particles, but in this case the particles are different sizes. And the note here says larger particles have greater mass. So if they have the same number of particles, which box has greater mass? Well, the box that has the bigger particles. They have the same number, so now we're looking at the size of the particles. Object C has the bigger particles, therefore object C has the greater mass. Again, if we're looking at volume, we're looking at the size of the object, so they look to be about the same size without getting a ruler out, and we're not going to. They look to be about the same size, so we're going to say that they have equal volume. So likewise, when we're looking at the density, we're still looking at the compactness, but in this case, the bigger particles take up more space. So even though there aren't more particles, there's an equal number, we have one object that just has bigger particles. The bigger particles take up more space, making C more compacted, which means C has the greater density. And that also makes sense based on these two comparisons. They have the same volume, but C has the greater mass, which should mean in the same volume, whichever has the bigger mass is going to have the bigger density. So that means C has the greater density. When we go the other way, when we go to draw particle diagrams, if you want to show differences in densities, there are lots of things you can vary. You can vary the size of the boxes, you can vary the size of the particles, you can vary the number of particles. So changing the number of particles or the size of the particles is going to change the mass. So if you have 2 boxes of equal size, but you need to show one having more mass, you can either have the same number of particles, but make them different sizes, so that one object has more mass because they have bigger particles. Or you can make the particles the same size, but one box is going to have more particles to indicate that it has more mass. You could also do this by changing the volume. If you keep the mass the same, but make one box bigger or smaller, you can use that to show how density is different between the two objects. The main thing to keep in mind is that density is a ratio between mass and volume. So it's not something that you can only change by changing one thing. You can change the mass, you can change the volume to, when you're drawing particle diagrams, you can change how you represent those things to change how you represent different densities.